Lesson 11. A few things before we get started. A quick reminder that division by 0 is undefined. You can try something like 10 divided by 0 in your calculator and you'll see that it gives you an error because there is no answer for dividing by 0. It's considered undefined. Since a fraction bar means division, the denominator of a fraction can never be 0 because you would be dividing by 0. If the denominator of a fraction contains any variables, we must exclude any value that would result in a 0 in the denominator. So on question number 1, it says find all excluded values for the expression, that is, find all values of w for which the expression is undefined. So we're only concerned with the denominator. So what we know is that 2w minus 8 can never be 0. So I use the symbol for not equal. So if I add 8 to both sides, 2w cannot equal 8. And if I divide both sides by 2, we're saying that w cannot be 4. So we must exclude the value 4 from ever being entered into this fraction. Question number 2. Find all excluded values for the expression, that is, find all values of x for which the expression is undefined. Now this time we have a quadratic that is a second degree in our denominator. And it can never be 0, and because it's a second degree, that means there are going to be 2 values we must exclude. So we use our difference of squares pattern, because look, x squared is x times x, and 81 is 9 times 9. And our pattern says you alternate these as conjugates. X plus 9, x minus 9 cannot be 0. That means that x plus 9 cannot be 0. And x minus 9 cannot be 0 because either one of those would cause a 0 denominator. So I subtract 9 from the first one, so x cannot be negative 9, and I add 9 in the second case, which means x cannot be 9. So the values to be excluded are negative 9 and positive 9. And now we're asked to simplify a fraction. Okay, and this is what we call a rational expression because it's a fraction with variables in it. So let's just look at a regular fraction and how we simplify. Let's say I have 24 over 40. The fastest way to simplify a fraction that's a numerical is to factor out the greatest common factor for each part. So this one is going to be 8 times 3, and this one is going to be 8 times 5. Because the greatest common factor of 24 and 40 is 8. And we talked about how to find the greatest common factor back in the test 2 material. Now once we have it in factored form, any factor that has an identical factor in the denominator will reduce to 1. And so in this case, we're left with 3/5. And of course, your calculator, if you do 24 fraction key 40, it will reduce it for you if it's numerical. But we have to learn how to do the ones that are algebraic. So notice what I did. I factored it completely and I reduced to 1 any common factor. Okay? So if I have 10v squared minus 15v divided by 5v squared minus 20v, I'm going to look to my methods of factoring. Now, if I start canceling here, I'm in trouble because I cannot cancel terms. Terms are things that are being added or subtracted. So I can't reduce it in this form. So I'm going to factor my numerator. 10 and 15 have a 5. V squared and V have a V. So once I take out the 5V, I'll have 2V minus 3. Then I need to factor my denominator. Well, 5 and 20 also have a 5, and V squared and V have a V, and that's going to leave me with V minus 4. Now I see that these are factors because they're being multiplied. Notice that there's a times in here. There's no add or subtract, so those can reduce to 1. And that's going to leave me a final answer of 2V minus 3 over V minus 4. Now, if you cancel out these V's or try to divide or reduce them, you're going to miss it, because remember, this is a term because it's part of a subtraction. So 2V and 3 are not factors, they're terms. They have to stay together. The same thing with V minus 4. So my final answer is 2V minus 3 divided by V minus 4. So in number 4, we have to look out for a couple of things. So let's just talk about this first. If I have A plus B divided by A plus B, no matter what A and B are, that's going to reduce to 1. If you do 2 plus 3, it would be over 2 plus 3, and 5 over 5 is 1. If I have A minus B over A minus B, that will also be 1, because no matter what the value of A and B are, those are going to be the same. And anytime you divide a number by itself, you get 1. If you have A minus B over A plus B, that will not reduce. Will not reduce. Okay? For example, if I have 10 minus 3 over 10 plus 3, that's a 7 over 13. 7 over 13 doesn't reduce because the numerator and denominator are not the same. And here's the tricky one. If I have A minus B over B minus A, that actually will reduce to negative 1. Let me give you an example. 10 minus 2 over 2 minus 10 is 8 divided by negative 8, and so it's going to reduce to negative 1. So opposites means it has to be in the opposite order, will reduce to negative 1. Now you may have to rearrange the terms to see which one of these you have. For example, if I have 2V plus 7 over 7 plus 2V, I'm going to rewrite my denominator, put it in standard form where the variable comes first and the number comes second. Those are identical, so that's equal to 1. Now we're not dividing the 2V with the 2V and the 7 with the 7. We're dividing the whole thing by the whole thing, and that ends up being 1. And when I have 8V minus 3 over 3 minus 8V, look, that's subtraction in reverse. Those are opposites. That'll be negative 1. Now let me show you the long way to get negative 1. If I rewrite my denominator as negative 8V plus 3, and I factor out a negative 1 from the denominator, I get 8V minus 3 in my parentheses. So the 8V minus 3 reduces with the 8V minus 3 and leaves a 1, and so 1 over negative 1 is negative 1. But if you just recognize that subtraction in reverse will result in negative 1 because these are opposites. Number 5, we have y minus 8 divided by y squared minus 16y plus 64. I cannot reduce terms. I must do factoring. And I notice in the denominator here, this is y times y, and this is 8 times 8. So I'm going to give this a try. Y minus 8 times y minus 8. because that is a perfect square trinomial. And if I check it, minus 8 and minus 8 will give me minus 16. So this is y minus 8 divided by y minus 8. Now, one of these y minus 8's will reduce with this y minus 8 and leave a 1. So my final answer is 1 over y minus 8. And you must have that 1 in that numerator. This is like reducing 2/10. If you have 2 over 10, that's not 5, that's 1/5, because it's 2 times 1 over 2 times 5, and the 2's reduce out, and that 1 has to be in your numerator. So the final answer for number 5 was 1 over y minus 8. So you can see how factoring is very important for this section. You can't factor, you're going to have trouble doing these problems. You may have to practice your factoring. Number 6, 25v squared minus 1 over 5v squared plus 24v minus 5. So I've got two kinds of factoring going on. I've got the difference of squares here. So that's 5v times 5v and 1 times 1. So the numerator is going to be 5v plus 1 and 5v minus 1. Now my denominator is one of those that requires the AC method, because whenever this first coefficient, the leading coefficient, is not a 1 and there's no common factor, we have to multiply A times C. So if I multiply 5 times negative 5, I get negative 25. So that's the number whose factors I need to find, and I need them to add up to 24. So negative 1 times 25. And look, on the very first one, that adds to 24. So I'm going to split my 24 term, and I'm going to write it 5v squared minus 1v plus 25v minus 5. And so all of this is just so that I can reduce this fraction. I have to get it in factored form first, though, because it can only reduce factors. So let's see. In this first two, and then the last two will get grouped, and the middle sign always drops down. I take a v out of these, I get a 5v minus 1. I take a 5 out of the last two, and I get a 5v minus 1. Now they have a binomial in common, 5v minus 1, and then my leftover factor is v plus 5. So I go back up here and I write 5v minus 1 and v plus 5. Now these are in factored form, because that means multiplication on the top and that means multiplication on the bottom. So the two terms that are alike will reduce to a 1. And that's going to leave me with 5v plus 1 over v plus 5. And if you try to reduce that any farther, you're going to miss it, because 5v plus 1 must stay together and v plus 5 must stay together because they're terms. Now we're going to multiply and divide fractions. So just a quick review of multiplying fractions. If you have a over b times c over d, you don't need a common denominator. You just multiply the top, a times c, over the bottom, b times d, and then you reduce it to lowest terms if possible. However, if you have common factors, a over b times c over a, even if those factors are not directly on top of each other, if one factor in the bottom is identical to a factor in the top, you can reduce before you multiply. Okay? So if I had 2 over 3 times 3 over 4 times 6 over 10 times 10 over 2. Before I multiply, I could do 2 times 3 times 6 times 10. That's going to be 60 times 6. That's going to be 360. So big numbers. On the bottom, 3 times 4 is 12, times 10 is 120, times 2 is 240. So I would have, if I go straight across the top, I'd have 360, and on the bottom, 240. And so those are big numbers, right? But instead, I can do some reducing first. I see a 3 on top and a 3 on bottom. That leaves a 1. I see a 10 on top and a 10 on bottom. That leaves a 1. I see a 2 on top and a 2 on bottom. That leaves a 1. And so really all I have is 6 over 4. 6 over 4 is 2 times 3 and 2 times 2. So this reduces to 3 over 2. Now 360 over 240, well, I can reduce those zeros out. That's dividing the top and bottom by 10. If I have 36 over 24, this is 12 times 3 over 12 times 2. And look, I still get 3 over 2. So you do not have to multiply out first. You can reduce first if you have factors, okay? If it's in multiplication form. When I have one like number 7, 18x plus 81 over 8x minus 40 times 4x minus 20 over 2x plus 9. Okay? I don't see anything that's identical, so I'm going to do some factoring. I'm going to start with 18x plus 81. I'm going to take out a 9. That's going to give me a 2x plus 9. Now I'm going to go down to this denominator, 8x minus 40. I'm going to take out an 8, x minus 5. Then I'm going to do my numerator, take out a 4, x minus 5. And there's no way to factor 2x plus 9, so it stays here. And if you want to, you can put it in parentheses. It doesn't have to be, though. So let's look for a factor on the top with an identical factor in the denominator. 2x plus 9 and 2x plus 9 leaves a 1. Okay? We don't just say cancels out. It's really division, so it really divides to 1. X minus 5 and x minus 5 leaves a 1. Then I see a 4 on the top and an 8 on the bottom. So 4 goes into 8, leaves a 2. Now all I have to do is look at what's left. Well, on the top, it's 9 times 1 times 1 times 1. So it's 9 over, and on the bottom, there's a 2. So number 7 reduces to 9 over 2. Number 8. 25x squared minus 4. I'm just going to go ahead and factor these one at a time. 5x plus 2, 5x minus 2. That's going to be my first numerator. Denominator, 2x squared minus 11x minus 21. Well, that's one of those AC problems because, look, I can't take out a common factor. 2 times negative 21 is negative 42. I need the factors of negative 42 that will give me a negative 11. So it's not negative 1 times 42 because when you add those you get 41. Let's see, negative 2 times 21, if you add those you get 19. Negative 3 times 14, if you add those you get positive 11. So that tells me I need negative 14 times 3. So since I know that my factors are negative 14 times 3, I can write this 2x squared minus 14x plus 3x minus 21. I'm going to drop my middle sign down, and I'll take a 2x out of the first pair, and that's going to give me x minus 7. And I'll take a 3 out of the second pair, that's an x minus 7 as well. And now I can see that the common binomial factor is x minus 7. So x minus 7 and 2x plus 3. So that's my first denominator. Okay, and again, I'm just factoring them out first. The 2x minus 14 for the second numerator factors as 2x minus 7. And the last denominator, 5x minus 2, is prime. It won't factor. So bringing all those factors together, I have a 5x plus 2 and a 5x minus 2. And then for the first denominator, x minus 7 and 2x plus 3. And then for the second fraction, we have a 2 and an x minus 7 over the 5x minus 2 that wouldn't factor. So what do you see that are alike? 5x minus 2 goes into 5x minus 2, leaves a 1. X minus 7 goes into x minus 7, leaves a 1. And then I look around and I don't see anything else. So the best way to write this would be put the 2 first and the 5x plus 2. Those are the two factors that are left on the top. And normally we'd put the number in front, but it's okay if you put it in the back, as long as that 5x plus 2 is in parentheses. All of this is over 2x plus 3. Now the most common mistake here would be to try to divide these 2's out. But remember, 2x plus 3 is a pair. They stay together because they're terms. You can't take part of 2x plus 3. So our final answer is this. And if you wanted to multiply out the numerator, you could. Or if you wanted to put the 2 in the back, you could. And those would still be correct. And our last one, number 9, involves divisions. So a quick review of fraction division. A over B divided by C over D has to be rewritten A over B times D over C. So you change and you flip. Okay? So to divide, you change and you flip. You change the divide to multiply, and the divisor, that is the second fraction after the divide sign, to its reciprocal, D over C. If you try to reduce before that, you will miss it. Okay? So in number 9, I have 14x squared minus 3x minus 5 over 5x plus 10. Now, I'm not even going to write the divide. I'm going to put times x plus 2 over 49x squared minus 25. So look, I've done my change and my flip already. Now, I'm going to go ahead and factor these so that I can reduce. So x plus 2 is not going to factor. I'm doing the easy ones first. And the 5 and the x plus 2 is here. Okay, that's that first denominator. 5x plus 10 is 5 times x plus 2. This one, the second denominator, is the difference of squares. 49x squared minus 25. Well, 49 is 7x and 7x. And 25 is 5 and 5. And you have to put a plus and a minus. Either order is fine. Now that tells me a little bit about this numerator. I'm probably going to have one of these. I don't know for sure, but I'm probably going to have one of these. So I'm going to go ahead and factor that down here. 14x squared minus 3x minus 5. That is negative 70. So the factors of negative 70, negative 1 and 70, negative 2 and 35, 4 won't go, negative 5 and 14, negative 7 and 10. Now look, that gives me plus 3, but I need a minus 3, so I know it's negative 10 and 7. So I'm going to split my 3x into 14x squared minus 10x plus 7x minus 5. Now, I might want to do that in the other order because the 7 matches better with the 14 and the 10 matches better with the 5. But I can do it in this order. I just have to remember that. I bring my sign down here, and since these don't have anything in common, it's going to be 1 times 7x minus 5. And the first two have a 2 in common and an x in common, 7x minus 5. So since they have a 7x minus 5 in common, it's going to be 7x minus 5 and then 2x, and that plus 1 is really important. That's why you got to remember to write the plus 1 there. So it's 7x minus 5 and 2x plus 1. So go back up here, 7x minus 5 and 2x plus 1. And let's reduce out what we see that are the same. I see 7x minus 5 and a 7x minus 5, and an x plus 2 and an x plus 2. That leaves me with 2x plus 1 as the only factor in the numerator. Remember, these are 1s, so there's only 1 times 2x plus 1, and in the denominator I have a 5 and a 7x plus 5. So that is the lowest terms for this division problem.